Having passed a few minutes in order to wait for people to join, I think we can start. And for this, I would give the floor to our moderator, Wael, that would start with the presentation. Thank you everyone for being here, and let's enjoy this session.
Thank you, Juan. Could you please put the presentation on? Yes, please. So let me check again if I have the control. Still. Yes. Okay. Thank you so much, Juan. Good afternoon, everyone, and welcome to the BIO4PACK Cluster Workshop, Shaping the Future of Sustainable Food Packaging. I'm very pleased to have you all with us today as we bring together experts and innovators working toward more sustainable, circular, and smart food packaging solutions. Today, we will explore how collaborative efforts are helping to replace fossil plastic, design for circularity, ensure safety, and harness digital technology to achieve Europe's sustainable goal. This workshop, I would like to mention that this workshop is recorded and all the materials will be shared with you once ready. Thank you for joining us again, and let's get started. So for today's agenda, first of all, as moderator, I welcome all the panelists from 4 Horizon Europe projects. Then I will introduce the cluster before giving the talk to our first project, VIS project. Then we move to Revolution project, Stop project, Magnum project, and by the end of the presentation of Magnum, we'll start our panel debate and Q&A before wrapping up on the workshop and ending it about 1 hour and 30 minutes from the beginning. So here you have our esteemed panelists. My name is Wael Hamd, and I'm the moderator. I'm very glad and happy to serve as the moderator of this interesting workshop. As for myself, I did a PhD in chemical processes and catalysis in France, and then several postdoc related to surface chemistry, photocatalysis, catalysis, and my area of expertise is mainly catalysis and the treatment of plastic and microplastics in seawater. Our first panelist is Dr. Carmen Fernandez. Carmen Fernandez is the head of coordination and R&D management at CETEC, the Plastics and Footwear Technology Center of the region of Murcia. She holds a chemical engineering PhD and has over 15 years of experience in the plastic and bioplastic sectors. As for our second project with Dr. K. Sigenthaler, so on behalf of Revolution, it was foreseen to be represented by Dr. Sigenthaler acting as the project coordinator. However, not being able to attend, Dr. Yannick Matt, also from BASF, will represent the initiative. I would like to let him introduce himself, if you are hearing me, Yannick, like in few words, before moving to our next panelist.
Yes, sure. Hello together. My name is Yannick Matt. I'm part of BASF since roughly 4 years. I'm a chemist by training, so traditional organic or polymer chemist, mainly working here on the condensation of polyesters, polyamide structures, and things like that.
Thank you very much, Yannick. Now we'll move to our third panelist. Milad Musalai is a researcher science at VTT Technical Research Center of Finland, working in the material processing and circular solution unit. His expertise lies in material science, circular economy, and stretchable electronics, focusing on developing sustainable materials and improving polymer recycling methods. He has contributed to several EU research projects such as STOP, which aims to reduce plastic packaging pollution. With a PhD in engineering from Tampere University, his work bridges applied research and innovation, advancing circular materials, sustainable manufacturing, and flexible electronic system for a more resource-efficient future. And at the end, we have our coordinator of Magno project, where I am a partner with my university, the University of Balamand. So our last panelist is Ignacio Fernandez, who is a Spanish chemical engineer and researcher at Edener AI in Seville, where he coordinates projects focused on industrial processes, modeling, artificial intelligence, and sustainability. His work integrates digital technologies with chemical engineering to improve efficiency, circularity, and innovation in industrial systems, contributing to several European research initiatives on advanced manufacturing and green technology. So, welcome to all our panelists in this workshop. Sorry for the delay in changing the slide. So before starting this workshop and giving the talk to our panelists, let's give you a brief idea about who are we. So BIO4PACK, regrouping these 4 important European projects, represent a bold collective effort to transform the way food packaging is designed, produced, and managed in Europe. At a time when plastic pollution, resource scarcity, and climate change are redefining global priorities, BIO4PACK brings together these 4 ambitious Horizon Europe projects, these projects, Revolution Project, STOP, and Magno projects, united by a single mission to revolutionize food packaging system and enable a sustainable, circular, and resilient bioeconomy. BIO4PACK is not just a research initiative. It's a collaboration platform that connects science, innovators, policymakers, and industry leaders to accelerate the packaging transition. The cluster's overarching goal is to replace fossil-based plastic with next-generation materials that are bio-based, recyclable, reusable, and biodegradable without at the same time compromising safety, functionality, or performance. So each project within BIO4PACK contributes a unique piece to the sustainability puzzle. If we start with this project, this is developing high-performance packaging materials that meet industrial standards while significantly reducing environmental footprint. As for the second project, Revolution focuses on designing and synthesizing novel biopolymers, offering viable, scalable alternatives to fossil-derived plastic. For STOP, is pioneering recyclable and compostable packaging solutions that close the material loop and make circularity a reality. As for the last project in this workshop, Magno project developed digital technologies such as traceability system and digital twin to enhance transparency, recycling efficiency, and decision-making. Together, these projects reflect the EU ambition to embed sustainability into every stage of the packaging value chain, from material sourcing and product design to waste management and policy development. So BIO4PACK aligns around 5 core objectives that define its strategic agenda. The first one is replacing fossil plastic. The second one, designing for circularity. Third one, ensuring safety. For the fourth one, harnessing smart technology, and at the end, contributing to new European standards and policy. So BIO4PACK's strengths lies in its interdisciplinary and cross-sectoral collaboration by linking researchers with policymakers and innovators with manufacturers. The cluster fosters a dynamic environment where knowledge is exchanged, best practices are shared, and synergies are identified. The cluster also serves as a bridge between science and policy, ensuring that cutting-edge research informs regulatory framework and that regulation in turn guide research priorities toward real-world application. This dual approach ensures that technology innovation translates into tangible benefits for consumer, businesses, and the environment. So the content of the BIO4PACK cluster will be divided in 5 main ideas. The first one is goodbye for fossil plastic and welcome to bio-based material. So we are pioneering a new generation of sustainable polymer packaging made from renewable and bio-based resources. So by replacing all derived plastic with material sourced from nature, we aim to reduce our dependency on fossil fuel and significantly lower carbon emission. So our research focuses on innovative polymers that maintain high performance while being fully sustainable, proving that eco-friendly design and functionality can go hand in hand. As for the second important idea from this BIO4PACK, we are closing the loop, circular by design. So our packaging solutions are conceived with circularity at their core. So from the very first design stages, we ensure that every product can be reused, recycled, or safely biodegraded. This circular by design approach not only minimizes waste, but also maximizes the value of resources throughout their entire life cycle. By rethinking packaging from the start, we contribute altogether to a truly regenerative material economy where nothing goes to waste. As for the third important point, we are working for safety. So this workshop also will inform us about the safer or the safety for people and the planet. Sustainability isn't just about materials, but it's also about responsibility. So every component we develop undergoes comprehensive health and environmental safety assessment, ensuring that our solutions are non-toxic, low impact, and transparent for production to disposal. Our goal is zero pollution and full material transparency, building trust with consumers and protecting both human health and ecosystem. The fourth point, or the fourth idea, is smart packaging meets smart tech. So we believe that the future of packaging is intelligent and connected. By integrating digital traceability tools, data platform, and digital twins, we can track packaging life cycles, improve recycling efficiency, and make better data-driven decisions. This digital layer enhances supply chain transparency and enables smart resource use, and also help industry and consumers alike participate in a more circular, informed system. The last point or the last idea is about shaping the future with the new standards and policies. So transforming packaging requires collaboration beyond innovation. That's why we actively engage with policymakers, industry partners, and research networks to shape the next generation of European standard for sustainable packaging. Through our contribution, we aim to set new benchmarks for safety, performance, and circularity, helping Europe lead to the global transition toward a cleaner, more resilient material future. So apologize for this a bit long introduction, and now I will move to our panelists. So let's start with the first presentation of today's workshop with Dr. Carmen Fernandez. Please join me in welcoming Carmen, the coordinator of this project. Carmen, the floor is yours.
Thank you, Han, for your nice presentation. I'm going to take the control. So, a ver. No, yes. Perhaps it's going with a bit of delay, no? Okay, good morning, everybody. As Gael has presented me, I'm Carmen Fernandez, the BIS Project Coordinator, and it's a pleasure for me to introduce the BIS Project today. The BIS project is a viable, safe, and sustainable PHBB value chain for food packaging application. The duration of the project is 4 years. It started last September of 2023 and ends in August of 2027. The consortium is formed by 14 partners for different European countries representing the BIS value chain, including waste providers, scientific partners like universities, technology centers, industry representatives from the food packaging industry, expert in safe, expert in sustainability, in exploitation, communication, and dissemination, and also experts in social science and humanities. Here you can find our project website and linking contacts. And okay, now I introduce the need of the BIS project. The BIS project arose from the need to develop sustainable alternatives to fossil-based plastic in the food packaging. One of the most promising bio-based polymers is the polyhydroxyalkanoids family, the PHAs. They are produced by microorganisms and have excellent biodegradation properties in relevant environments, in soil, in fresh water, in seawater. Also, they have good technical performance. And within PHA's family highlights the PHBB copolymer, the poly-3-hydroxybutyrate or co-3-hydroxyvalerate, because it can modulate its properties according to the comonomer content, according to the hydroxyvalerate content. However, PHBB has some challenges to overcome. The PHBB had production costs due to the high costs of the feedstocks. In fact, current commercial PHBB has low hydroxyvalerate content, about 2%. Due to PHBB production requires costly precursors to increase the hydroxyvalerate content. And thus, commercial PHBB has some problems on the processability. It has a narrow processing window, slow processing cycles, and it's necessary to blend it with other polymers for industrial applications, hindering the biodegradation. This slide summarizes the BIS project approach and how we overcome the previous challenges. The BIS projects produce PHBB by an innovative combination of residues from the agri-food industry as feedstocks and thus decreasing the production cost, decreasing the cost of the feedstock. We use sugar waste from the sugar industry as a carbon source and feathers and bones from the poultry industry as nitrogen and phosphorus source. Also, the sugar waste are used to produce precursors of the hydroxyvalerate, decreasing the cost of the precursors. Later, the PHBB is produced by a fermentative process using microorganisms. These are extremophile microorganisms which do not require sterile conditions, decreasing the processing costs and the energy requirements. These microorganisms can accumulate PHBB with high hydroxyvalerate content. And to obtain PHBB with very high hydroxyvalerate content, we can use the precursors obtained from the residues. And also, we implement a green process for the extraction of the PHBB. And then later, we obtain a PHBB range with high hydroxyvalerate content, modulating the properties during its production. This high hydroxyvalerate content enhance the processability and the flexibility of the copolymer. And we can modulate the properties according to the hydroxyvalerate content, obtaining different copolymers with different properties. Later, the PHBB is formulated and compounded using safe additives selected under a safe and sustainable by design framework, while not hindering the excellent biodegradability properties of the PHBB. The PHBB compounds will be converted into flexible and semi-flexible food packaging for the sugar and vegetable industries. We develop mesh bags, trays, envelopes, and bags. All this packaging will be biodegradable and mechanically recyclable based on PHAs. This approach is demonstrated at Tier 8 and is developed under a safe and sustainable by design framework, integrating economic, social, and environmental assessment. This slide represents the current status of the project. We have optimized the process for the production of the PHBB from residues as feedstock, and currently we are finalizing the construction of the demo plant for the production of the PHBB. In these photos, you can see the main units of our demo plant. In the upstream side, we have the poultry residues hydrolysis unit and our bioreactor rooms for the fermentation processes. And in the downstream side, we can find all the units, the tangential filtration, evaporation, and extraction to obtain the pure PHBB. Then, after this process, we obtain a PHBB with high hydroxyvalerate content, going beyond the state of the art. We have optimized the production of 2 grains of PHBB with 10 to 15 hydroxyvalerate content and from 20 to 30 hydroxyvalerate content. Then when we increase the hydroxyvalerate content, the crystallinity decrease. Then the polymer enhance its flexibility. As you can see in the table, we achieve higher values of elongation when we have our higher hydroxyvalerate content. Also, we have formulated the PHBB with safe additives, obtaining a stable PHBB for the conversion processes. Now we are working on blending the PHPP and converting it by conventional processes into the final target packaging. Our first trials have been developed by cast sheet extrusion and thermoforming to obtain trays and blowing extrusion to obtain the fields. Then we have completed our first pilot scale test, which had been successful. And finally, these are our expected project results and outcomes. We expect a sustainable production of PHBB with a high hydroxyvalerate content, which is quite innovative. PHBB safe and sustainable formulation for flexible and semi-flexible food packaging application, biodegradability and recyclability of our products, and the adoption of a value chain under a safe and sustainable by design framework. In our expected outcomes, we expect the reduction of the CO2 emission compared to the fossil-based counterparts, contribution to circularity by recirculating the byproducts processes and using residues as feedstock, less toxicity material because we use safe additives and substances. And another point is to enhance the consumer awareness about bio-based plastics and the market acceptability. And this is all from my side. Thanks a lot for your attention. I invite you to follow us in our social networks, visit our website, and also you can contact us in this email. Thank you very much.
Thank you so much, Carmen, for this amazing presentation, the informative presentation. We'll have the time at the end to ask you some questions about the process. Now, let's welcome our next speaker, Dr. Yannick Matt, who will be representing the Revolution Project. Yannick, over to you.
Yeah, thank you. I just took over the controls, I think. Let me quickly check if that works. Yes. So yeah, our project is the Revolution Project, and as already in the introduction described, our target is to develop 100% bio-based aliphatic aromatic polyester and blends thereof, producing them in pilot scale, and these blends and polyester should be completely biodegradable in the relevant environments, as well on top as technically recyclable. We are designing them for very specific applications in which the biodegradability adds a certain value. In this case, it's food paper packaging, so trays, for example, as well as agricultural mulch foils, where, for example, common materials at the moment is polyethylene. On top, we want to show best-in-class performance in terms of the processability of this material and its performance in the application. Second objective that we have is to provide insights in sustainability performance and address challenges for the implementation by doing LCC and LCA analysis and by giving policy recommendations based on the results that we find within our project. So the project partners are shown here on the map. They are distributed across Europe. So from north to south, from Finland, it's Stora Enso, who's taking care of the paper coating and transforming the coated paper into something like coated coffee cups, so single-use coffee cups, for example. Tampere University, which is also part here, is also responsible for the paper coating. Then we have Normek OWS, they're sitting in Belgium. They're responsible for the biodegradation, part of the biodegradation experiments. Avancium from the Netherlands is responsible for delivering the furane decarboxylic acid, which is the workhorse in our bio-based toolbox for producing the polyesters. Then from Germany, it's Hydra Marine Sciences. They are also part of the biodegradation team and testing biodegradation in marine and limnic environments. BASF, we are doing the polyester synthesis and blends and then distributing everything to our partners. ETH Zurich, the university is taking part also in biodegradation studies. And then we have CTP in France. They are there for paper coating and printing applications, and Contactica from Spain, who's also here in the panelist, I think. I've seen Estibaliz, who's they're responsible for example, for our communication within the project here. So we have this overview slide, which at the first look might be a little bit confusing, but let's go through it from top left. Can I somewhere add a laser pointer here? No, I can't. So I hope it's enough to describe it. So on the upper left, it's the raw materials. We start from starch, for example, from wheat processing, where it's a side stream. And then Avantium is having a special process where they transform the starch into furan decarboxylic acid. Together with other commercial available bio-based monomers, for example, something like BDO or propane diol, butane diol, succinic acid, azelaic and sebacic acid, we are having a nice toolbox to make polyesters. And we're doing that then within BASF, the polycondensation on the lab scale to find a suitable recipe, as well as afterwards the blending of these polymers into a blend that's targeted for the specific application in the end. So from here on, we supply the material once to the partners who do biodegradation testing, which is ETH Zurich, it's Hydro Marine Sciences and Normic OWS. Each of them has their own field of expertise. And simultaneously, the material also goes into the processing work packages. So for example, there is the temporary university then, which is using this blend to do paper coating. Same time, we also want to do mulch foils, so we in BASF go into film blowing these materials. And then we have these materials for the specific application, the coated paper for food packaging, the blown films for mulch films in agriculture. And then we're looking at the end of life scenario for these materials. So it can be mechanical recycling in the end to close the loop. It can be composting applications because the material should be biodegradable in the end. And we are also looking at unintended losses by use. So for example, mulch foil, which on the field is ripped apart, and small pieces of that is going into rivers and streams and ultimately going into the ocean. So we're here looking at how is this material degrading in different environments. What we could achieve so far is the lab scale polyester synthesis based on this bio-based monomer toolbox that we have was very successful. We used a digitally supported approach here, which is called DOE for design of experiment, where we do, let's say in the chemical space, different experiments, check the properties, feed it back into the system, and the system predicts us which composition in the polyester will probably bring us the best results in the end. And that way we were able to identify lead structures that we then upscaled in a pilot scale process from lab scale was a few hundred grams now to several hundred kilograms of polyester in batch polycondensation. And we took this material then and went into a blending step, which was then specifically made into two different blends. One of them is the paper coating blend, which then goes into food paper packaging, and the other is the mulch film blend, which goes into agricultural films. The paper coating step was also done just a few weeks ago in Finland. It was very successful. So we have coated paper boards now that can then be transformed into coffee cups, food trays, and so on. And on top of that, first trials at film blowing to make the agricultural films was also very successful here within BASF. Simultaneously to the material side of the project, we were, as I said, looking also on the biodegradation methods here. So we were looking at enzymatic hydrolysis. We were looking at respirometric biodegradation in various environments, so industrial and home composting in agricultural soil, for example. And then on top, developing methods for marine and limnic degradation studies. And Contactica, our project partner in Spain, is then also doing the methodology for life cycle analysis here for our project. On our website, we have some information sections because for people, it's sometimes hard to differentiate when they're not coming from science between what is bio-based, what is biodegradable, meaning what is microplastic. And for these topics, we have three learning sections about bio-based materials, about biodegradable materials, and then to understand microplastics a little bit closer. So if you're interested, please have a look on the project homepage. What we have to achieve still is the finalization of all the biodegradation trials of the final blends in the various environments. This can take long because some soil biodegradation just usually takes a year or two to finalize and get the results. Also see the mechanical recycling trials of the polymer blends after they have been used as well. Then downstream processing and evaluation of the coated paper. So at the moment, we just have the coated paper. It needs to go to partners like Stora Enso to now make coffee cups and see if that process works properly with the material. On top of that, large-scale film blowing and mulch film field trials are also something that we want to do in the future. Due to winter season coming, we're not doing that now, but we're starting now and plan to start with the actual field trials then in the next growing season, which is starting March, April next year. Also want to finalize the LCC and LCA studies based on the project results until the end of the project, and want to give policy recommendations or at least work out a guideline for that. The project officially ends end of May next year. So still a little bit time left to finalize these things. So because he's not here today and we're asked to give a quick overview about the project coordinator as well, this is Kai Siegenthaler. He studied in the KIT in Karlsruhe and then at the University of Marburg, a little bit of Cambridge and Münster. And he's in BASF since 2007 in different roles. So started in research and development, then went into strategy and innovation management. I was also a commercial product manager. Now he's back in central research, leading this project. Same for me. I studied in Karlsruhe and I stayed there, didn't go anywhere else. Took a research stay in Scotland at the University of Edinburgh and joined BASF 2021 as a lab team leader for condensation addition specialties, where we take care of polyester synthesis. So if I'm not mistaken, that's it for the Rebiolution project, and I can pass over to the next one.
Thank you so much, Yannick, for this clear and interesting presentation. Thanks a lot. So now our next speaker is Milad Musallai, the coordinator of STOP project. Milad, over to you.
Thank you very much, Wael. Thank you. Let me first check if the slide is running. Yes. All right. Good morning, good afternoon, or good day, everyone, and thank you for joining us for the workshop. And thank you very much, Wael, for introduction of the cluster, the aim of these four projects, and also introducing me. So I think you already introduced me as the coordinator of the project, so I will skip this slide and I'm jumping to the next slide. About the project, our project, the name, the acronym is STOP with 2P at the end. And the project name is the strategies to prevent and reduce plastic packaging pollution from food system. And it was funded under this call that you could see on your screen. And I think two projects, I mean us at STOP and also our sister project Magno, were funded under this call. So it's a 3-year project that started beginning of January 2024 and will end at the end of 2026. And yes, going to go to the next slide. I don't know why it's not running here.
Please click on the screen first and then try to control the slides.
Okay. Yes, I think now it's running. So about the project partners, so in this consortium, we made 14 partners across the Europe, in which five of us are from Finland, including VTT Technical Research Center of Finland, the organization that I am from, and we are actually the lead beneficiary of the STOP and coordinating the project. Then we have University of Vaasa, HSY, Ekokumppanit, and Pirkan Maniatahuolto. Then we have National Institute of Biology and National Institute of Chemistry from Slovenia. Green Delta, Braskem, and Remondis are our partners from Germany. Plastic Recyclers Europe is our Belgian partner. Veolia from France and Sustainable Innovation Europe is our partner from Spain. And last but definitely not least, Recircle from Switzerland. About the project, STOP, we are actually an initiative to transform the way that we are approaching food packaging by working with all the stakeholders in the value chain. So here we are encouraging the 5 R's, which are refuse, reduce, redesign, recycle, and reuse and recycle. And our main goal here is to dramatically reduce the environmental impact that are caused by plastic waste in food packaging. So the concept here is to stop the way of operation that leads to environmental pollution, use of unsustainable virgin fossil resources, excess uses of resources and insufficient use of products, and incineration and landfilling of plastic waste materials. And then produce strategies for plastic packaging circularities with those 5 R's that I mentioned earlier. So about the impact of the project, we expect to achieve the following outcomes, which are like a deeper understanding and increased knowledge on the impacts of litter plastic, food packaging on the ecosystem, and adoption of more sustainable business strategies, design, and production model within the food packaging value chain, increase awareness and acceptance about the importance of sustainable and circular food packaging solution, and technological development to increase reuse and recycling of sustainable packaging. And the project has defined the 5 specific objectives, as you could see on the screen, that are to analyze the plastic impact on diverse ecosystem, then supporting the transition of key stakeholder toward alternative circular solution in food packaging systems by like identification of their needs, motivation, and creating practical tools. Then developing future fit sustainable business model blueprint for packaging value chain, including raw material, recycling, and reuse scenarios. Increasing recycling from the collection and sorting practices. For instance, here we are producing recommendation to improve collection and sorting. And then consumer studies and awareness campaign to engage over 10,000 European consumer in topics such as like reusable packaging or behavior change to improve awareness, acceptance, and uptake. So the project has 8 work packages in which I try to write the corresponded work packages for each like specific objective. And regarding the achievements of the project so far, I would like to tell you that we recently, not recently, before the summer, we had our first periodic report, which was between months 1 and 18. So we prepared the report and different activities within the project. So luckily, we are not behind our activities. And I'm mentioning the achievements that are 100% done during the first periodic report. Of course, there are a lot of like tasks that they had progress since we are in like months 20, like third of the projects, but I decided to just mention the one that are fully done in the project. So create a comparative analysis of main challenges, barrier, good practices, and state of the art of food packaging system, including single use, reuse, and recycle. And this work has been done, and we finalize everything in the deliverable 3.1. The name is state of the art food packaging systems, and this deliverable somehow is a report that maps the current state, challenges, and future directions for sustainable food packaging in Europe, with a strong focus on enabling circularity through reuse, recycling, and innovation. So I try to leave the hyperlink here. If you are interested to get more information, please feel free to have a look in our website. And then create a quality quantity match model of available material alternatives to match producers, recyclers, packaging converters, and end users. So the result of this piece of work is reported in deliverable 3.3, which is adoption of alternative food packaging solution. So this report somehow examines what drives or blocks the shift toward a sustainable food packaging. So it is based on the interview that we had with 40 stakeholders, and it highlights the motivators like regulations, consumer demand, barriers such as cost and technical limits, and future trend. And then, and of course, we introduce a tool called quality quantity match model. And then we have the produced future fit sustainable packaging business model blueprint. In here, the report is done in deliverable 3.2. And I encourage you that if you would like to get more information, just have a look on that. It reviews the current and emerging circular business model for plastic food packaging. So it looks ahead to possible future scenarios for a fully circular industry, and at the same time look back to identify the key strategies that need to be implemented between 2025 or 15 years ahead. And then also the behavior, packaging disposal behavior that is done. So this report analyzes how consumers dispose of food packaging on the identifying habits, barriers, and motivators for proper recycling. And okay. And then before we end off my presentation, I would like to ask you that if you still haven't joined our community, we have a community called multi-actor community. And I somehow added the QR code here. So I promise that we are not bombarding you by a lot of emails. So it's just 2 emails per year. And if you go there, you could register there and show your interest toward recycling or reusing or both. That I encourage you that you choose both. And when you become a member of this community, you will be invited to activities in the staff like webinars, workshops, and you will be like the first benefit from project result. And also we let you know about the workshops that we have. And last but definitely not least, for the first periodic report, we already provided all 8 practice abstracts, and I somehow left the link to both project website and also the EUCAP network, and please feel free to have a look on that. So thank you very much for your attention and patience. So back to you, Wael.
Thank you so much, Milad, for this very interesting presentation. And now we'll move to our last speaker for today's workshop, Ignacio Fernandez, the coordinator of Magno project. Ignacio, please, the floor is yours.
Thank you very much, Wael, for introduction. I also want to thank everyone for being here in this meeting, and for the organizers, our colleagues from Kivilos. So I'm going to start with the presentation of the Magno project. As Milad mentioned earlier during his presentation, both Magno and STOP were funded under the same topic. So we are sister projects that are tackling the same problem, but with different approaches and focusing on different, I would say, strategic areas of research. I'm going to first give a brief overview about the members of the consortium. So first, to the top of the screen, you have Edener. So Edener is an SME located on Seville. We are the coordinators of the project, and our focus in Magno is the development of software that is can help stakeholders across the value chain to analyze and model the food packaging value chains, testing different materials, different types of packaging, and analyzing results in terms of materials needed, energy consumed, wastes generated, and the environmental impacts that the different configurations of the value chain have. Next, we have European Plastics Converters, which is located on Belgium and is focused around the later stages of the value chain in the project. So that is collection, sorting, and also is supporting us in the standardization and policy making recommendations. Next, we have the Fraunhofer Institute from Packaging and Process. That is located on Germany, who are the technical coordinators of the project. So we have dual coordination between Edener and Fraunhofer, and their focus of activities are on materials and manufacturing techniques for plastic packaging. Next, we have Olos. Olos is a company that is located on Portugal, which are developing the life cycle sustainability assessments of within the project in Work Package 5. Next, well, I think Carmen has made a very good introduction already of CETEC. CETEC is working on Work Package 3 in Magno and working on materials for sustainable packaging. Then we go to Iris. Iris is a company located on Spain that is helping us in developing the database for the ecosystem digital twin, and also in other digital activities within the project. University of Balaman, which Wael is the representative here, they are the leaders of Work Package 4, and in conjunction with the University of Sousse and the National Institute of Science and Technologies of the Sea, that are both located in Tunisia, they are working on the analysis of impacts of plastic within health and the marine environment. Next, we have DNV. DNV is an international company that is focused on among other fields, on logistics and quality assurance. They are working on the exploitation and also on the analysis of different aspects of the value chains tied to logistics. And finally, and most importantly, we have our colleagues from Kivilos, which are the dissemination and communication managers within the project, as Juan is present in the meeting. So What is our focus and what we are trying to do within Magno? Our approach is to develop a series of strategies in order to reduce plastic packaging pollution from the food system. And in order to do that, we are having an holistic approach of the value chains, and we are not focused on any specific technology development such as Revolution and this, which are, if I am not mistaken, innovation actions where they are scaling up technology prior to its commercialization, but rather we are analyzing how innovative materials such as renewable, biodegradable, or recyclable materials can have a positive impact. We are analyzing how the design for circularity can reduce material consumption and increase more environmentally friendly end-of-life options such as reuse and recycling. Also analyzing how is the impact of the substitution of harmful substances in packaging formulations, and analyzing smart solutions to monitor food quality and extend the product shelf life. As for the specific objectives within the project, we are identifying effects and impacts of plastic food packaging. We are developing a series of innovative business strategies based on our analysis of the food packaging value chain. And we also want to include governments and the general society in the food packaging system. So to give some examples of our analysis on the impacts of plastic packaging on the environment and human health, I have included two of the scientific papers that have been published during this year. They are open access, so they can be consulted by everyone. In terms of, the impacts on the environment, microplastics can have a significant impact on the disruption of ecosystem as microplastics accumulate in marine and terrestrial ecosystem, and can have a significant impact on food chains. They also harm directly marine life, such as creating blockades on digestive systems and the exposure of marine life to toxic chemicals. And soil and water contamination is very significant because microplastics and nanoplastics can impact soil quality, and then it is introduced on plants, affecting plant growth and also freshwater habitats. In terms of the impacts to human health, among others, we have identified significant impacts to the immune system with increasing the potential carcinogen risks for humans. These microplastics can be introduced into the system through both inhalation and ingestion, which also can produce significant cellular damage. As for one of the innovations that we are developing within the project, I want to introduce the Ecosystem Digital Twin. So the Ecosystem Digital Twin, it's a software that we are developing in-house that is going to enable us to analyze the food packaging value chains. And we are going to use this software as a decision support tool to validate the novel strategies that we are developing within the work packages of the project. Such as, for example, what is the impact if we are analyzing a specific type of packaging, such as trays, and we use different manufacturing techniques, what are the energy consumptions, what materials are needed, and how this is the impact on shelf life. So therefore, using data from packaging materials, manufacturing techniques, end-of-life approaches, we can assess environmental impacts, economic costs, and waste generated for each strategy, which is quite important because, as I think everybody knows, Europe is the European, or the countries that are in the European Union and also outside of the European Union have very different economies, have very different value chains. So there is not a single solution that can help everyone, but rather different countries have to, and different stakeholders can analyze with the use of this ecosystem digital twin what are the best options for their own production processes and for their own value chains. Complementing our modeling approach, we are also developing a generative AI tool based on a large language model in order to complement the results that we are obtaining from the different work packages to feed data for the ecosystem digital twin database. As a brief summary of our circular approach for the food packaging value chain, here in this slide, you can see that we are analyzing mainly two types of two preferable options for the end of life of products, which are recycling and recovery, since incineration and landfill are not sustainable options. So with the development of the project, we want to promote the development of products, system, and business models that can also promote reuse and recycling options for the value chains and develop a series of circular solutions. As I mentioned, there is not a single solution that can fix everything, but rather a series of circular solutions to different alternatives for the current linearity of the value chain. Furthermore, with that, we also want to reduce significantly the impacts of plastic packaging production and consumption whenever possible, and as key business model to highlight returnable and reusable packaging are quite important, considering also the implementation of the Safe and Sustainable by Design framework by the European Commission. As a brief summary of the results of the project, I have included here the 5 scientific publications as open access that can be both consulted in the respective journals, but also that are available on Magnus and other repository that is a part of the European Union Open Research Repository. To mention some of the research results, we have some reviews for the food packaging used and post-consumer plastic waste management, for design, new materials and production challenges of bioplastic-based food packaging, for both the impacts of plastic pollution for food packaging systems in the human health and the marine environment, and finally, food packaging business models that are drivers for sustainability in the food packaging industry. Similarly to our project STOP, since we are sister projects, as part of our obligations with the European Commission in the grant agreement, we have already a series of practice abstracts that are available in our website and also in the European CAP network. And we are engaging during Work Package 2, thanks to the guidance of DMV, in a series of bilateral meetings to understand what are the main stakeholders' challenges across the food packaging value chain. And this collaboration is enabling us to gather feedback and insights in order to formulate actionable strategies. That is the core developments of the project, development of strategies to reduce food packaging pollution that can be implemented in real world environments. So I'm also leaving here the QR code to join our multi-actor community. And that should be all from my side. Thank you very much for your patience. And now, I leave the floor back to you. Thank you.
Thank you so much, Ignacio, for this very interesting presentation about Magno project. Thank you all. Let's thank all the panelists, Carmen, Yannick, Ignacio, and Milad, for your input in today's workshop. And now we will move to the debate session. We have prepared some questions prepared on Mentimeter, and you will have some options to answer. We'll have some few seconds for each question, and at the end, I will be invite our panelists to comment on the result. I guess, Juan, that we have some time to ask the full list of questions, right?
Yes, what we will do now, sorry, is invite you to take a picture with your mobile phones or directly access our Mentimeter through the link here and go through some questions that will help us in order to move forward within the debate and also to input some questions then for a Q&A session. For this, I will let you a couple of minutes to enter the survey and check that question while I open Mentimeter in order to go on with the presentation.
Thank you, Juan. So please, you can scan it and to enter to this survey in order to answer a few questions. And then we will be back to our panelists in order to comment or to have some input from their side. So if we're ready, Juan, are we ready?
Yes, I think so. I think only one person answered, so I
So the
think
first
you are
one,
still.
what activities would you like us to set up to help your transition to more sustainable packaging? Okay, so for the time being, we have 50-50 between two answers to explore, or it's changed now, 40 to 60%. So between the life cycle assessment and to explore eco-friendly material alternatives and cost impact. Anyone from our esteemed panelists would like to add something or to comment on this first question?
Yes, I want to add that I think it's important to support for pilot scale validation because many promising bio-based material, like for example, bio-based plastic require testing under real industrial conditions. Then access to pilot lines, validation platform is also important to bridge the gaps between the lab and the market. For example, financial and political support is necessary to overcome the high costs associated to the scale up. Then policies on bio-based packaging or safe packaging to stimulate the demand and reduce the investment rates could be also an important point for the transition to sustainable packaging.
Thank you so much, Carmen, for your input. Let's move now to the second question. So the second one is about what does truly sustainable food packaging mean and how can we measure it across materials, life cycles, and geographies? Few seconds, please, to answer this question. I invite all of you to participate to have more accurate percentages, please. Still not being able to see the results. Let's wait a few more seconds. Meanwhile, maybe I can ask Milad, what would you answer to this
Yeah,
question? Which option
I
you have selected?
so I think they are important in many sense, in different senses, but I would also go for packaging that balances environmental, social, and economic sustainability at every stage. Because if you're considering it's the truly sustainable should be in a way that it somehow supports like job creation, economy, and also consumer acceptance, beside the fact that we know that, okay, we need to take care of the sustainability, greenhouse production, etc., etc. But it's a trade-off. We can't close on our eyes in one aspect and go for some other aspects. That's why I think it's really important that we make balance with different like parameters and make trade-off between them. So I think this packaging that like balances these aspects is, in my opinion, it quite makes sense.
That's great. Also, at the same time, we have the highest percentage on this choice as well. So packaging that
Yeah.
balance environmental, social, and economic sustainability at every stage. That's great. Thank you, Milad. Now we'll move to the third question. And it is about, is it more effective to prioritize fully recyclable packaging or biodegradable alternatives, or should Europe pursue a hybrid approach? So either recyclable, biodegradable, or a hybrid one. So major answers on the hybrid model. Yannick, do you want to add something on this question, please?
Yeah, I also opted for the hybrid model. I think it's very important in which place you look in the world. Central Europe probably has a very good system in collecting plastic waste and then sorting and going into recyclables. We look at other places in the world where that's not easily possible, then I would probably opt for something that's more easily biodegradable. So I think it's strongly depending on where you're moving in the world here. So hybrid model probably tackles both things equally and then is most suitable for around the globe.
Exactly. Thank you, Yannick. Thank you so much. And now
sorry,
anyone
maybe
else? Yes, please.
Maybe I also add one thing, as Yannick
Yes, please.
mentioned, I totally agree with him. But also, I think more than like the location, geographical location, also we need to consider about the application, because sometimes when we think about the application, it's not. It's better to use less biodegradable options and focus, for instance, more on polyolefins or vice versa. That's why I think in my opinion, adopting the hybrid model would be the answer here.
That's great. So we all agree to have the third option as hybrid model as answer for this effective approach for Europe. Let's move now to the question number 4. So it is, how can digital tools like traceability systems and digital twins transform recycling efficiency and consumer transparency? So I will be asking Ignacio to be prepared to answer this question as well.
So I think I'm going to give him my answer. Meanwhile, everyone is commenting.
Without waiting the result. So, okay.
Okay.
Please go ahead, Ignacio.
I would say in general, I think it's also going to resonate by everyone's answer from the previous questions. Cost is if not the most, one of the most important aspects for sustainable solutions to be taken into place. So in here, traceability systems and digital twins can not only increase the information and knowledge the different actors across the value chains, but not only raw materials producers, but also logistic companies, also recyclers have, in order to ensure transparency and sustainability and safety is maintained. Because one of the issues that different stakeholders have mentioned to us during the bilateral meetings is that the traceability for recycled polymers, depending on the application, as Milan mentioned, is quite important, and there is some migration from different waste streams into some recycled streams. So traceability can ensure that European industries and industries in general can remain competitive, ensure safety on the recycled materials, and provide consumers, but not as only general society, but rather the different actors of the value chain, to make more informed decisions and to ensure that the solutions that you are planning to implement are effective, are safe, and everyone knows what is the path forward, I would say. And in terms of the digital twin, I know it's a long answer. I think digital twins can, as the ecosystem digital twin that we are developing on the project, can help make informed decisions. Because at the end of the day, not everyone is an expert on life cycle assessment. Not everyone is an expert on the different polymers that are available for the market. So information to stakeholders, to every actor on the value chain, to consumers, to recyclers, to manufacturers, is key to ensure that sustainable alternatives are put into motion.
Thank you so much, Ignacio, for your input. And as we can see, yes, so traceability platform can track packaging for production to disposal, ensuring accountability, and data analytical enables government and companies to identify bottleneck in recycle chain are the answers of this question number 4. And finally, the last question for today is, what policies or incentives would must effectively drive companies to adopt bio-based material at scale? So maybe I will ask Carmen or Yannick again, because you're working on this bio-based material in your project, while waiting the other answers. So please feel free to give us your input.
Yes, I think a combination, for example, green public procurement is important because policies on bio-based and safe packaging can create a stable demand and foster the industry investment. And also harmonized standards are very important, especially around biodegradability, because there are a lot of gaps in biodegradability, and it can contribute to accelerate the market for bio-based solution. And of course, tax to push companies to support R&D, pilot plan, scale up activities can help promising technologies reach the industrial maturity that is sometimes quite complex and costly. Then this is also an important part.
Thank you, Carmen. Yannick, you would like to add something?
Yeah, I think overall companies are driven by two major things. One is what their customers want to buy. So initiative to inform customers about there is bio-based materials available. We could do it, but customers really need to ask for it and be ready probably to pay higher prices for that. On the other hand side, it's often regulation driven. So I think it's always a multi-channel approach to bring big companies to adopt bio-based materials at larger scale in the end.
Thanks a lot, Yannick. Milad and Ignacio, if you would like to add something, please feel free to say what do you think about.
Well,
If not, we
actually,
can... Yes, please.
yeah, I wish you didn't ask me this question, because for me it's very difficult to somehow pinpoint one of these answers. Obviously, I would choose, well, I did first and last one. I think they are very relevant. But as Carmen said, also the harmonization of the EU standard is important. So I think here it would be combination of them. For me, it would be a little bit difficult to prioritize or put them in order. However, again, the first one makes sense because it's a good incentive for especially companies. Yeah.
Thanks, Milad.
Yeah.
So I think that the questions on Mentimeters are now finished. We can move to the last session of our workshop, which is about the Q&A. So if you have...
Well, since we are not much people here, perhaps we can have a live discussion based on hand raise, and this way we can have a much interesting exchange, perhaps rather than structure the Q&A input.
So again, do you want us to discuss the list of questions?
No. It's about if anyone else, either within the panel itself or from the attendance, have a question, please raise your hand and go ahead.
Yes, that's it. Yes, please. So we'll see if someone is raising her hand from the list of participants. If not, I would like just to ask Carmen a short question, please. So Carmen, my question is, what is making your product PHBV different from the other bio-based materials in the market? Is it like the mechanical properties, the easy to synthesize, the cost?
The cost is we are working on it because it's a real challenge for bio-based material. But compared to the PHBB in the market, PHBB in the market has no flexibility, no flexible properties. But in our polymer, we modulate the crystallinity of the polymer with the copolymer content. Then we can modulate the properties. Then decreasing the crystallinity with our process, we can improve the processability of the polymer. That it's an important problem with the PHBB in the market. But also we improve the flexibility. Then it makes a proper polymer for flexible application, like for example fields or trays. Then it's an important advance beyond the state of the art and beyond the PHBB in the market. And also we work in using waste as feedstock. We use extremophile microorganisms. Then we don't require sterile condition. Then we reduce the energy consumed in our process. Then with all of this, we decrease the cost of the production of this polymer.
Thank you, Carmen. I'll check it. Please.
Just out of curiosity, Carmen, about one of the slides that you were presenting to us about the material that you developed. For instance, one of them is PHBV, 20 to 30% 3HVs. You mentioned that elongation and break is 21.3%. Out of curiosity, is it like returnable or not?
Is what?
I mean,
Sorry?
after you stretch it, does it go back to the original shape? And if it does, is it like it takes a lot of time that immediate it goes back?
No, immediately goes back. It's elongation at break. Then we break the samples.
Yeah.
Yes.
Nice.
But it's a good result in comparison with the conventional
I can see that,
commercial PHBB. And yes, we are working on this, on increasing the hydroxyvalerate content to modulate the properties and to have a runs for different applications.
I see. Yeah, thank you.
Thank you, Milad. Thank you, Carmen. We'll see if we have
I have a quick question from my side to Carmen as well, because I think it's very interesting the work that you are doing on this. What I wanted to ask is that, considering that the formulation of the material are polyhydroxyalkanoids, you have an advantage against other polymer materials, since you are not mixing different blends such as polypropylene and polyester, for example, in the product, so that makes it more apt for recycling process. So that is very interesting. The improvement of the processability also helps you with the mechanical recycling?
Yes. In fact, we are now in the step of the project to test the mechanical recyclability and the biodegradation. But we work with monomaterial because all the blends are only based on PHA. Then it's an advantage for both the recyclability but also the biodegradation, because PHA has excellent biodegradation properties. Then we don't hinder the biodegradation properties of the PHA. Then it's also an important advance in the project.
Great. Thank you.
Thank you, Ignacio.
Thank you, Ignacio. Thank you, Carmen. Maybe I would like to ask finally, Yannick, a short question about your product as well. Is there any toxic intermediate from your biodegradable products, since you're working with aromatic components?
Yeah, this is a very good question. We're actually also looking at ecotoxicology by doing real-life studies, as well as modeling our intermediates that are set free during the breakdown of the polyester, doing both simultaneously, though the simulation approach and the field trial approach, to answer this question at the end of the project.
Thanks a lot, Yannick. So I think that no one from the list is asking or would like to ask anything. So Juan, maybe we can go to the closing remarks.
Yes, for sure. We are just in time. We are 1 minute after behind schedule, so feel free to wrap up.
Okay, so thank you so much all for being part of today's BIO4PACK cluster workshop. It's been a pleasure for myself to moderate such an engaging and forward-looking discussion. We truly appreciate the insight shared by all our speakers from the 4 project and the participation of everyone who joined us today. And finally, to stay connected, I'm inviting all of you to keep in touch and to follow us on our social media channels for updates, upcoming events, and collaboration opportunities. Thank you once again and have a wonderful day ahead. Thanks a lot.
Thank you. Have a good day.
Thank
Thank you very much for everything.
Bye-bye.
Bye-bye.
See you soon.
Thanks a lot.